All right, so here's the first activity that we are going to do. Um, like the last one, there's an online version of this that we can do. The simulator should work on Chromebooks and tablets. Or you can gather the stuff. There's not that much stuff to gather, and you can do it for real. All right, so this is what it's going to look. So here's the main objective is to determine the value of the force constant of a spring using Hooke's law. So this is Hooke's law that we've talked about, right? So if we want to figure out what the spring constant is, what the K value of something is, then we can write it like this, right? And that looks a lot like this, doesn't it? Slope is equal to rise over run. Well, so we can use that fact that if we figure out a few different forces for a few different x values, then we can plot that. And this is what you guys are going to do. We are going to make a graph, better than this graph, it's going to be on graph paper, where you are going to plot Fs versus x. And then what should happen is that you get a straight line. It should end up like in a straight line like that. Remember that if you have data points, something like that, you're doing a line of best fit. We care about the line going through more than where the data points are. Do not connect the dots. Okay, so then remember slope is just rise over run, so you can take any place on this graph, figure out the rise, figure out the run, and this should be your value of K. So we just had, so yeah, if you figure out the slope of this, that should be your spring constant for your spring. So the way that would look, if I pause this thing, we're going to be able to just, we should be able to just hang a spring from here and we can make a measurement on that, right? So if this was at 0, you're going to want to go to the center of mass is where we're going to want to make our measurement, but that's pretty much how you're going to be able to do it. This is 100 grams, so you can pretty quickly figure out what FG would be in that case. One thing to do on this one though that it won't work, if you turn your friction off, so there's no friction, you won't be able to get this thing to stop. It's going to bounce forever. So if you want to get it so it actually stops, you need to turn your friction up to something. You might as well turn it all the way up to full, and then it'll eventually come to a stop, and then we can use that to figure out our spring constant. Okay, so you are going to use the materials that were provided or the ones that you found. Plot a graph like I showed you over here of force and distance and your position. And we are going to be using these different masses. Again, it actually doesn't matter which masses you use. You can use pretty much anything. So if these aren't the masses that you have at your school, don't worry about it. Just use what you do have. 5 points is what I would like to have. If you only have 4, then I guess we got to deal with that. So you have to calculate Fs, which is really just going to be mass times gravity, right? It's going to be the same as Fg. And then measure that, and then make a graph of it. Your write-up should have a data table like this and observations, neatly plotted graph, and calculation of the slope. And then also a free body diagram. So remember, free body diagram is, well, you know what a free body diagram is. FG and FS. I probably gave too much away. All right. Activity number 2. Okay, same thing. We're going to use that same simulator, or you can, if you already have the materials, then it's pretty much the same materials for both of these labs. What we are going to do, oh, you don't need graph paper for this one, my bad. What we are going to do is do pretty much the same thing, but we are going to use our new formula that we have for it. So we're going to do that. And then in this one, though, we are going to, you could probably turn your friction down to none for this one, or, low. We're going to use different masses, and then we are going to figure out what our vibration time is. So you'll have to try your best to figure out what the time is. So you can start at the top and then count, right? So You want to do 10 vibrations, so I would start it when it's at the top. I'd go start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that was for 10, right? 6.16 seconds. Okay, and then your period would just be divided by 10, and then you can figure out what your K value is using your formula. So that's how you're going to find it. So you got to rearrange this formula for K, and then put that in for there. Hopefully that made sense. Okay, so that's what you're going to do for that one. And then number 2 up here says calculate the average value of the spring constant. To find the average value of all these, all you're going to do is, let's say you have 5 or 4 numbers here. You're going to add those 4 up and then divide by 4, right? Just like you'd find the average for any number. And then compare the results. Which one do you think was better? Why? And then, yeah, so that's going to be it for that. So both of those things are due before the next lesson. So I'm going to end that one there, and good luck.